Good morning. This is the third lesson of the cycle about agent-based models. And welcome to everyone. As usual, we start from a look to the homeworks. I received again a lot. I missed you.
The answer to the previous
The previous one, yeah, but yesterday, no.
Yeah.
Try to send it again to me, please.
I'll read when you make.
And the context of being awake has been run by Daniel Mora, who sent the work at 3 o'clock. Too much. Too much. Anyway, I saw it only in the morning. The last I saw was at 2:25. So it is a nice contest. And from Elena. Second in staying awake. And my compliments, a lot of work, a lot of stars. Maybe that offering larger pizza is an incentive very good for your works. Anyway, I am very satisfied, but this is not an evaluation. This is an interaction. And for me, it's very important to interact with you. Let me introduce a general comment, then a few specifications. First of all, here we have a monopolistic attempt of controlling the market. Pay attention. Pay attention. Europe forbids monopolistic position, so don't increase your market power. Anyway, nice, you see, they are expanding. No, very nice. Anyway, the general point is that with this homework, you have been discovering that adding actions is complicated. It is annoying, it is creating confusion, so we need a cleaner tool. You will see then that when we will introduce this mechanism, having a clock opening boxes, and having boxes containing actions, and having two clocks, most of all, one for the model and one for the observer. So the clock for the observer will control the output of the data in graphical or numerical form. And the clock for the model will control the action of the agent. Anything will be simpler and clear. At the end of this lesson, I will show you a very complicated model, very complicated. I don't know how many hours of work I put there, but the presentation of the sequence of the action is simple. And so it is possible to understand how to modify, how to add, how to change, and so on. Okay, this is the general comment. A small thanks to Nicholas, because Nicholas has introduced an interesting addendum about variable in classes. I don't know if it was working in Python 2. I have to control. But my Python 2 has the same problem of Cesare. Where is Cesare? Not Cesare. I'm mixing the names. The student with the problem with the idle. Giorgio, sorry. We have not Cesare here, so it is a new entry. I have the same problem that you had I have it for Python 2. So I have to install the same correction I suggested to you, but I want to control that before having other problems, because this is a different operating system than yours. So it's not a good idea to do that before the lesson. If I stop anything, it's not a good idea. And I want to control that. If in Python 2, it was possible to do that action. That action is also solving a problem that Elena introduced to me yesterday. How to modify for all the agents, modifying a variable or creating a variable, something. And I show you the idea coming from Nicholas, coffee. So
actually, it was your idea.
Sorry?
It was your idea. I just implemented. You told about.
You added something.
Methods,
so it's worth for a coffee. So I owe two coffee, one to Rule, correct?
Yeah.
And one to for Nicholas. Okay. I show you again the file about the classes of yesterday with this addendum. And it is this one. This is in Python 3. Anyway, we have to use now Python 3 because Python 4, the specifications of Python 4 are around. So maybe next year we will have the first version of Python 4. My son is 45 years old. He's an entrepreneur in machine learning, deep learning application. And he told me, please stop using Python 2. They are defining Python 4. Okay. Stop. And the addendum is this one. I run. Okay. Now, considering the class, I add with the dot specification B. B is not existing now, you see, we have no B. But I add B. So class A dot variable B equal 100. Now A1 knows B. And what it is interesting, B has been introduced after the creation of the instance. So this means that anything is dynamic. It's not static. The instance is looking for the content of the class when it is asked to do something. This is very interesting. And it works, sure. And this is a way for introducing as an example a logical variable, true, false, and stopping an action or starting an action. Very good.
This is by reference or by value?
This is by value. B is an address, as always. Yeah. But the content is the value, so we have to pass, the reference, the address.
Thanks,
The address. So it is possible to modify it.
So if you modify it,
the trick is this one.
No.
Let's see. Now, A1B for sure is 200, for sure. And A2B, 100. So it is by value. Don't pay attention to these very complicated things. They are very interesting, but we can avoid. Anyway, anything in Python is always an object, also a number. If I ask for the ID, so the identifier of A1A, this is the identifier unique of this value. If another similar value is used, it will have the same identifier. So this is creating some internal problem, but the speedness is increasing. Anything in Python is the key of a dictionary. Please discover this wonderful function. Sorry. Globals as a function. This is the specification of our memory. And you see, here there is the instance A1, the instance A2, the class A. A and B are, well, A and B are missing. No, they are locals. They are not globals. We can continue. And the main idea that Guido Rarossum had creating Python has been this one. Anything in Python is a key of a dictionary. What a dictionary is a collection with names. This is the simpler way of imagining a dictionary. I can jump into the collection and ask for the age of Pietro, not the age of the guy in position 4. Okay? We will use dictionaries. Now I stop because the menu for today is already sufficiently filled of things to be done. Last specification. Some one of you had the problems with append. It's very simple. No mystery there. We have two ways of managing a simple collection, one-dimensional collection, so a vector. One way is specifying the dimension of the vector, filling it with zeros. This vector, V, has a length of 3. Good. So I can write V in position 2 equal 9. Okay, it works. If I want to add an element to V, it is very simple to do that using append. That means add another element at the end. I can also fill an element within. We have a lot of possibilities. But the simpler one is append. V dot append 11. If I ask what the methods for V are, I wait. And you see we have extend, index, insert. Insert is inserting an element in a given position. We have a lot of possibilities. Again, V is an object. So all the reverse, very simple. Sorry, this is a method, so. Again, rule asked reference of value. V is an address. So we have to pay a lot of attention to this kind of operation. W equal V. Okay. But this is an address. So if I change an element at the address Piazza Barello 8 and another element is in the same place exactly, I will change also the other vector. But I can copy the content by value. If I write Z of all elements equal V of all elements, sorry, Z has not to be specified. Now, Z is this one. If I change again V of 0 equal to 2, 2, 2, V as the new first element, but Z is always the same. Is a huge difference. If I copy W equal V, I am copying the address in memory where V is placed. If I copy the elements of V, I am creating a new collection. Let's check the ID. The ID are, I raise a bit so you can read easily. Impossible. No problem, sorry. Ok, I will. Grazie Valentina, buongiorno. ID of V, okay, this address. ID of W, the same. ID of Z, another one. So they are in two different places in the memory. My bureaucratic task finished. Very heavy task. Okay. This is coming from your homeworks. Sorry. If I use append, I can start from a vector G defined empty. The len of G is 0. Use round parentheses. The len of G is 0. If I append to G something, now G contains one element and so on. So if I have to use a collection with an ex ante unspecified dimension in the beginning, a good idea is that of creating an empty collection and then increasing it, appending elements. Also NetLogo is doing that with the complicated structure L put, F put, last put, first put. But the syntax is a bit annoying because you have to write twice the collection. Let set collection, L put element collection. Something like that. Okay. Oh, another element correcting your works. Please don't use exit within your Python code. Exit does not exit from a cycle, exit from the program, killing it and exiting in error. Because Python has no finish instruction. Python simply finishes. No more to be done. Stop. If you put an exit within it, you will raise an error. This is good because in my Slack I control a lot of possible wrong situations. When a wrong situation arises, I send a message. Pay attention, the world is exploding. Okay? Exit. Sure. But the first message is explaining why we are killing the program. So don't use exit as a normal structure. Also break is bad programming. If possible, avoid also break. Professor of the University of Torino in the 70s demonstrated with a theoretical work. Terrible, I forgot the name of the professor. We had 2 stars in computer science here in Torino. One is Professor Bergo, he is still alive, quite old, but well behaved. He's always working. And the other one demonstrated with a theoretical work that it's possible to write any kind of code without bracket, without stop, and without goto. Always structuring the code with the while, for, and so on, until simplifying a lot the reader of the code. And now I finish making my consideration. Okay. You see, your program is still running. Do you want to kill it? Because we had a program waiting other requests. Now I want to finish exactly, so I accept to kill the code. But don't use it, if possible, within your creations. Okay. Now the new lesson. Lesson 3. Then we will have a break and we will restart on November 9th. Content. On works, done. Collection of agents, done. Time management, this one, done. Agent management via collections, but I want to add also in this case a didactic specification. Let's see this example. I have again the previous code, this one. We can use it to do a lot of examples. If I create a vector, you know, here I have both A1 and A2, okay? If I create an empty vector, then I add A1 and A2. These are the addresses of the agents within the vector. So if I ask V position 1, I am working with agent A2. Let's demonstrate. A2 dot A2. V of 1 dot A2 is the same. And this is facilitating a lot the structure of an agent-based simulation. Because I don't need to create names for all the agents. It will be crazy. Remember, there's an agent A1, the other is A9, and so on. I put anything in the vector, and upon the vector I can use a cycle. Let's see. For an agent in V, print NA dot A. In the first step, NA contains the same address of A1. In the second step, contains the same address of A2. Simple. All the structure of SLAP is based on this kind of construction. finally, the last introductory consideration is about interaction. How can I interact from create interaction between two agents? I need to know the addresses. If I know the addresses, I can do anything. Agent A1 can ask to agent A2 its value of A, simply sending the get A to the address of the agent 2. In my slap, all the agents know the address of the collection of the agents. The morning we are being too awake in the night, and then me too. But then it is a bit difficult to start. We need 15 coffees or something like that. Pay attention, not more than 2. There was a comics of the cat Garfield. I need 17 cups of coffee to be awake. A bit too much. Because the cat Garfield is drinking coffee in the comics. In my slab, all the agents have the address of the collection of the agents. As an example, if I want that an agent asks to another one with a structure similar to one of the logo, something, simply I extract randomly from the vector one of the elements, and I send the get method to this address. Okay, this is perfectly consistent with object-oriented programming, because anything is an object, anything has an address, anything has specified functions that I continue to name methods, also when Python 2 has changed the internal naming, considering also the methods as functions. We start now considering again NetLogo. This is the last step in our class of agent-based simulation made with NetLogo. We will restart using NetLogo in the second course, that of network analysis and agent-based simulation, because we will take in consideration the powerful new library of NetLogo about networks. NetLogo has two extensions about networks. The first one has the name networks, and the second one has the name NW. NW is a lot more powerful than networks. They still distribute networks simply for compatibility reasons, but all the investment is on NW. You perfectly know, I guess, the use of breed, but let me just spend a few minutes about that. With breed, we can do very interesting creations, but also introduce a lot of errors in our code. Because breed is simply a name in a variable, but NetLogo is able, in changing the content of a turtle, if the turtle is changing breed. And this is not declared. You can read all the handbook and you never find this information. I discovered to my expenses, sure. And the solution is always the same. If you don't understand something, you can try to search in the web, someone has already had the same problem. This is sure. Let's see this code. This code is not simple, but as it is forbidden to create a code like that for managing a model, it is allowed to create a code like that for didactical reasons, because I want to explain you the problem. So please don't use this as an example of good programming. This is an example of bad programming, creating or errors. Let's see. First of all, I increase the size. You know that breed is defining a family of agents. All the agents are always turtle. So the superclass turtles exists always. After breed, you have two names. The first name, plural, is the name of the collection. The second name, singular, is the name of the agent. Maybe the name can be also different. It's not controlled in any way. It's in our mind that one is the collection, and so we have to put there a name easy to be memorized. As an example, I can name the collection industry and the element firm. In my mind, I remember the industry is the collection of the firms. Here I use simply A's and A, B's and B. Okay, plural and singular. I create 3 and 3, and I put around the agents. Let's do this step, and then we will continue examining the situation. I have to increase this because I want to click. Simply the patch now is 15. Then we will decrease it again. If I click on this, A1 inspect, this is an A, and you see here in the breed variable there is the name of the collection, A's. Okay? If I modify here the name B, it works. Now, clicking here, this is no more an A, it is a B. So the structure is simply based upon the name in the variable breed. But if I declare that the A's own a given variable, let's go back here because now is no more, no, it is still important. I add here A's own I don't know, the variable v. Setup. This agent is an A. Good. The variable v is here. I transform it in a B. V, no, B, non V. Sorry. B. I can't increase the probe. You see, V disappeared. So internally, NetLogo is mapping the structure of the variable related to the name of the breed. This can be very powerful, but also very dangerous. when we change the breed. I have an example. I will show you when we will work with network analysis. A network of firms. An agent can be a worker or it can be the entrepreneur. So we change the breed and the entrepreneur will have other variables than the worker. And in Python it is not so simple to do that. And my trick is I need to have a class changing specification, is that putting all the possible variables within the class and then controlling when a call, a method is sent to the class, if actually the class has now a specification of the other one. We will see. Then I added in SLAP also the possibility of having different classes because in some cases it is better. Let me reduce here the size. It was 5. Again 5. Now we pay no more attention to this. We want to see the messages here. This is a simple way of having the messages not in the bottom of the window, but clearly reported here, also with a scrolling capability. And this is this widget, the output widget. The output widget can be invoked only once. So as I use it, it is gray, and it's no more possible to create other outputs. It is a pity that we cannot create a second map of the world. It could be interesting. There is a way to do that. If you link R to NetLogo, you ask to R to plot the world. And so you can have two different views of the world. It is always possible to link different structures. Maybe very complicated, but it's always possible.
It's a live stream between the two?
Absolutely. I will show you that in network analysis. And you have to imagine that you have a server, virtual server, within your computer, offering an address where R is replying. You invoke that address and you have the reply. The problem is that you have no control over the syntax because the error messages are jumping in the void because you have not a window upon R. You have only a window upon NetLogo. Also, Python and R are working very well together in a simpler way than NetLogo and R. But I had just a minute of that. I had a very interesting situation with Professor Magda Fontana. We were discussing with other persons for the research center in Netherlands, the research center of Petten, where they study for the European Union the behavior of households upon age. And they have a lot of models, a lot. But as everywhere, coordination is always failing. So Daniel wrote the model in MATLAB, I wrote the model in Python, and Rule offending him is writing in NetLogo because he's never writing in NetLogo. Anyway, we have to coordinate. The first reply has been link anything to R. R will be the bridge. Yeah. But only in Windows because R has a huge bug in Windows. It's not able to separate the memory from different cores. So he has a unit memory space. Not a good solution based on the bug. I made another step. There is a wonderful tool written in Italy by an open source producer, receiving a lot of money from huge companies to develop this tool named Reddit, connecting any kind of environment via virtual memory. Very interesting. Complicated, but very interesting. So if you need to connect very different environment, remember that it can be costly as mind, but it works. It is possible. What if I use mode 1, modification 1? Modification 1 is asking to Mr. B3 to change the breed. Now, who is Mr. B3? Python is numbering only the turtles. So, as I have created 3A and 3 B's, Mr. number 3 is the first of the B's. The first of the A's is 0. The second is 1. The third is 2. Stop. Now, Mr. 3 is a B. Complicated. But the reason is that the internal structure of NetLogo has a unique class, the class tub, and the breeds are only a name trick. So Mr. B now, B3 is the first of the B's. Mode 1, okay, is an internal action. Now I use mode 2. Mode 2 asks A3 to set the breed again to B's. Is the reverse action. Okay? Not easy. Possible, but not easy. Do you want to check? Show B's. Ah, no, this is the collection. Not relevant. We cannot check. We have another method, I guess. No method. The final trick is modify one of B's. We have a print star to demonstrate that we are acting. Let my be one of the B's. If my B different from nobody, ask my B set B the A's. This is important because maybe we have no more B's, so we have to check. Nobody is a very important element in NetLogo. It works, and you have the effect here. Ah, sorry. Let's go back. Set up again. Look at this counter. Okay. Now we have 4 A's and 2 B's. And now we are again at 3 and 3. But the problem, just a specification, the problem is that if I repeat this, the second time, we go in error. Because B3 is no more a B, is an A. You have a question?
Similar. Because I was thinking, if you press setup and then mode 2, it gives the same error.
Again. Let's check. Let's check. So this is bad programming. But I show you that just to ask you to memorize that managing breeds in the logo. Specifying breeds is very good, but managing them is not simple, and it creates a lot of errors. And final demonstration, setup to have the clean situation, modify one. Okay, the star means worked. Again. Now it continue to act, but after 6 we are no more doing changes. Okay, stop. Save, nope, discard, anything. 2 final exercises with the NetLogo version of the didactical step about object-oriented programming with many bugs, shuffling them, and modifying attributes. Shuffling them is very simple because automatically, internally, NetLogo is always shuffling the agents, remixing them before executing. Unfortunately, control equal does not work because NetLogo does not map the keyboard of other languages, so the equal is placed in a different position if compared to the US keyboard. If someone of you has a US keyboard, it is better. What we are doing here, we can use to do versions for each or ask. If I comment this and this, and I uncomment this, we are shuffling the agents. In the other case, we are sorting them to have always the same sequence. Yesterday, if I remember correctly, it was Elena asking for the, no, it was Giulia? Cecilia in Italian, asking for the question mark. It means simply what element we are looking for, the first element to which we are pointing. So for each means we move to the first, to the second, to the third, and we want to interact to the first element pointed in the step of the cycle. If I wanted to have the first and the second, I will have question mark 1, question mark 2. Again, not easy for our mind. But these are addenda to NetLogo to solve specific operations. We can verify that if I set up and go, the sequence is always 0, 1, 2. So if I need to use a rigid order, this is the way. Any question? Oh, the handbook contains the help. So if I want to know anything about for each, quick help, and I have all the explanations. The author of NetLogo are very synthetic, but also they are never missing the explanations, but the terrible case of the breeds. Okay. This is very interesting, but it's very complicated. The use of unspecified functions, but the jump is not working. Anonymous section of the reference, not of the dictionary. Sorry. If I want in NetLogo to use a structure without defining it, I can with this possibility, and I can map the result also. Do you know what map means? Means in any language to apply a function to a collection, as to map in math. It's the same. To map from a number space to another one. It's the same. Oh, final step. The same, very close, but with the capability of modifying the attributes of our agent while the program is running, and this is very nice. You certainly have already done that, but just to specify the possibility. Here we have two participants coming from the doctoral school that never saw the logo, so it is a good idea to show them also these elements. For you, if you want, we can look at our agenda to have a conversation about Python. Also, the other one can participate, but the other one knows perfectly Python now, and I want to interact with you. So at the end of the lesson, I have just a minute to specify when. And in this case, while the program is running, with the usual trick of extracting from a random distribution a value and comparing it with the threshold, we change, I don't know, the size, the color, and so on. So you know very well all these, and the effects are like this. So we have the agent displaying and modifying the display. You see that the output is reducing a lot the speediness of the program. Just to demonstrate, if I comment the type, you see, immediately finished with 50 ticks, the same number of ticks before I was spending a lot of time just for the show. Okay, I conclude here the parallel examination of the same problems in Python and NetLogo. We now continue in Python, but we make a short break to save the file.